Okay, welcome to Business 271, Chapter 4, Introduction to Probability. This is Dr. Yohe. Here's a list of some of the things we're going to be looking at. We will probably make it through probably half of this, and then we'll do the other half in another video, as I'm limited to 15 minutes per video. All right, the first thing we're going to look at is probability as a numerical measure of the likelihood of an occurrence. Now here, what you have to remember is all probabilities are less than or equal to 0, greater than or equal to 0, less than or equal to 1. So they're going to fall on the scale between 0 and up to 1. Now, if an event is very unlikely to occur, it will have a small probability close to 0. A probability of 0 means that it is impossible, that it cannot occur. On the other side, as the probability increases closer to 1, that means that the event is almost certain to occur as we get closer to 1. An event right smack dab here in the middle is 50-50. The occurrence of the event is just as likely as it is unlikely to occur. An example of a likelihood of occurrence or probability for a coin flip. There's a 50% or 0.5 probability that a coin will come up heads. Now, when we look at all the possible occurrences of an event, say a coin flip, there are only two. We can have a heads or a tail. All of the probability would be included in heads and tails. So a heads, it's a 50% probability. A tails, 50% probability. You add that up to 1, it is certain if you flip a coin, you're going to get either a heads or a tails. Now, we're talking here about a random experiment, which is a process that generates well-defined experimental outcomes. These underlying terms here are things you want to make sure you have definitions for, so you might want to write them in your notes and study these. Okay? So a random experiment, a process that generates well-defined experimental outcomes. Flipping a coin one time is a random experiment. The sample space for an experiment is the set of all experimental outcomes. So if we flip a coin one time, the sample space is heads and tails, heads or tails. For rolling a dice, one die, the sample space is a 1, 2, 3, 4, 5, or 6. That would be the sample space. An experimental outcome is also called a sample point. So if I flip the coin right now, it came up tails, that would be a sample point. Here's a number of experiments and the experimental outcomes. We've talked about tossing a coin, rolling a die, inspecting a part. Say you work in quality control at the Goodyear plant. If a tire comes off the production line, its possible outcome, its experiment outcomes are it's either defective or non-defective. If you're conducting a sales call, you get a sale or no sale. If you're playing a football game, you get a win, a loss, or a tie. Random experiment in a sample space. Here, we've got Bradley Investments, and they're considering two investments, or they're going to make investments in two stocks, Markley Oil and Collins Mining. And we want to know, what are the possible outcomes of these three investments 3 months from now? So Markley Oil, Bradley has determined, it could make us $10,000 3 months from now, $5,000 3 months from now, break even, or lose $20,000 3 months from now. Collins Mining, that investment could make us $8,000 3 months from now, or we could lose $2,000. Here, we're going to use what they call a counting rule for a multiple step experiment. Bradley investment can be viewed as a two-step experiment. It involves two stocks, each with a set of experimental outcomes. There are 4 experimental outcomes for the Markley oil experiment, and there are 2 possible outcomes for Collins mining. We can multiply N1, which is the number of experimental outcomes from Markley oil, times N2, which is the number of experimental outcomes that can come from Collins mining, 4 times 2, and we can get 8 experimental outcomes that are possible. To make sense of that, we can look here at Markley oil and Collins mining. We'll start with a $10,000 gain. If you invest in both stocks 3 months from now, you could have a $10,000 gain from Markley oil and an $8,000 gain from Collins mining. That would be great. Or you could still have that $10,000 gain from Markley oil and lose $2,000 in Collins mining. So that's 2 possible outcomes so far. If we got $5,000 from Markley oil, we could get that plus an $8,000 gain from Collins mining. That's one outcome or potential outcome. Or we could still get that $5,000 gain from Markley oil and lose $2,000 on Collins mining. That's 2 more outcomes. We can do the same thing here. If we broke even on Markley oil, we could break even and still make $8,000 on Collins mining. Or we could break even and lose $2,000 on Collins mining. That's 2 more outcomes. That's 6. Plus 2 more outcomes if we were to lose $20,000 on Markley oil. We could do that and make $8,000 in Collins mining. Or we could lose $20,000 in Markley oil and lose $2,000 in Collins mining. That's 2 more. That's 8 possible outcomes. So you can see how this formula works with common sense. Now, another rule that we have, or counting rule for probabilities, is what we call a combination. The number of combinations of n objects taken n at a time. Big N is the total number of objects we're picking from. So maybe you have 10 shirts, and they're white or blue or green. We could pick 2 shirts from the laundry pile, and those 2 shirts, each one could be blue, white, or green. The other one could be blue, white, or green. Okay? So we want to know the different combinations of shirt colors that we could pick from 10 shirts, 2 taken at a time. So 10 would be the number of objects. N would be the number of objects that are taken at a time from these bigger N objects, the number of shirts. So 2 objects taken at a time out of 10 shirts. Now, the formula for this is written down here. Oftentimes, we'll say 10 objects, select 2. Now, when we do a combination, the order we pick the shirts in is not important to us, only the colors. So if I pick a blue one and then I pick a green one, that's no different than if I pick the green one first and the blue one second. Just the fact that I have a blue and a green, that is one possible combination. N factorial, that's on top here. A factorial simply means that you multiply all of the positive integers between n and 1. So if big N was 2, I'd multiply 2 times n minus 1 times n minus 2 all the way down until I got to 1. Here, that's 2. That would be 1. This would be 0. 0 doesn't count, so we stop here. I'd multiply 2 times 1. 0 factorial, we get 0 factorial. That is always equal to 1. Now, if we had 10 factorial, we're picking out of 10 objects, 10 shirts, the top of this would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That can also be done on your stat calculator. We'll create a video later to show you how to do that. Little n factorial, that's the number of objects we're taking, so that would be 2 factorial. 2 factorial would be 2 times 1. Now inside these brackets here, we have capital N, which is 10, minus little n, which is 2, that would be 8. So 8, and then the factorial, 8 factorial, would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? The answer to that question would be 45 different combinations of shirts. Now remember, combinations, we do not care about the order the items are selected in. If we do care about the order the items are selected in, then we have what's called a permutation. So here, if I pick a blue shirt out and then pick a green shirt, that's not the same as picking out a green shirt than a blue shirt. Those would be 2 different permutations, even though they would be counted as the same combination. So we're going to have more permutations than we have combinations of picking those shirts out of a pile. You can see that here because the equations are basically the same. Here's the combination equation. And you can see this n factorial goes away when we get to permutations. That makes the denominator smaller for picking 2 shirts out of a pile of 10 shirts. That makes the number of permutations greater. We can use our stat calculator to do this also. And the way you do it is you turn your calculator on, you enter little n first. So we're picking 2 shirts, so we'll hit 2. Then you go to the PRB button. That is the second row middle button. And if you look there, it'll say little n PR, little n CR, and then there's an exclamation point for factorial. We're going to do a permutation. So we're going to leave the little cursor underlining them at NPR and hit enter. And then we're going to hit 10 equals. My fault, I had that backwards. Whoops. We're going to hit 10, the PRB button, hit enter because we're on permutation, NPR, and then we're going to hit 2. Then we're going to hit equals. And that'll give us 90 different permutations. Okay. So you hit what is on the slides is capital N first, the PRB button, select NPR, that's permutations, hit enter, then hit the 2 and the equal button, which is also the enter button on the calculator. All right, that is about all the time I have for this video. We will continue this on video number 2. Thank you very much.